Okay, so a little bit about scientific notation and exponents. I'm going to look back just a minute, so some of that will make more sense. So this is stuff you already know, obviously. So 1 is the same thing, generally speaking, as 1.0, or 1 and 0/10. That implies you haven't measured very accurately. That implies you've measured to the nearest tenth of a foot, or tenth of a whatever the unit is. So 1 times 10 is 10, duh. 10 times 10 is 100, equally, duh. Okay, 10 squared is the same thing as 10 times 10, right? So 10 times 10 is 100. So we know that 10 squared is also 100. Now we get to the negative exponents. So all that means is the negative means you're using it as a fraction or as a part of a number. So this is 10 to the negative 1 is the same thing as 1/10. 10 to the negative 2 is the same as 1/10 times 1/10. So that equals 100th. So it also equals 0.01 or 100th, right? Okay, so that aside, keep that all in mind. Now we're going to go way back to 2nd grade, I believe. 2 times 3 equals 6, my favorite problem in the world. 2 groups of 3 each equals 6 total things. So keep in mind that phrasing, however many groups of however many in each group, and that gives you your answer. So with scientific notation, we're talking about amounts. So we're talking about how many things you have, basically. If you have 10 times 10, you have 10 groups with 10 in each group. So it's 100. So you have 100 things. So 10 squared is 100. 1/10 times 1/10. So you have 1/10 of a group with only 1/10 in it. So you have 100th of a whole thing, right? So scientific notation rules. You only have 1 digit before the decimal, always. That's the rule. It's got to be 1 through 9, and it has to be the only thing in front of the decimal. The base is always 10, and exponents can be must be a whole number, but they can't be 0, but they can't be positive or negative. So you can have a 0 exponent, but not for scientific notation. Exponent is positive for a large amount and negative for a small amount. Okay, so that's that out of the way. Why do we need scientific notation? I taught science too, so we talked a lot about like large clumps of things or really, really tiny things. There are large clumps of atoms in a human body. So you don't want to say, well, I have 10 billion quadrillion Googleplex atoms in my body. You want to say I have 7 and about times 10 to the 23rd atoms in whatever. And that way you can just think of it as an amount. It's easier to compare too when you can use scientific notation. So we'll get to that. So if I want to write, I don't know, 600 and, oops, not and, because that would be decimal, 632 in scientific notation. So let's look at our rules again. We can have 1 digit in front of the decimal, so I have to make 6.32. My base is always 10, and then this exponent up here is going to be a whole number, positive or negative, we don't know. So looking at that, I have 632 elephants, right? Whatever I have. That's not the same thing as 632. So let's make it even easier. What if I had 600 elephants? That's not the same thing as 6 elephants, but what can I do to 6 to make it be equal 600? I would multiply it by 100, right? So I know that 10 squared is the same thing as 100. So that's telling me that 6 times 100 is the same thing as 600. So those amounts are equal. So if I say 632 is the same thing as 6.32 or 6 and 32 hundredths times 10, am I there yet? No, because that would only be 63 and 2/10. So, but if I make it 63, 6 and 32 hundredths times 100, I get the same answer. So that kind of makes it make more sense when you're talking about actual amounts that are the same number. They're just said in different ways. That's the same thing as that is the same thing as that. That's the same thing as that, same thing as that, and that. So that's just 4 different ways to write 1,000. 1 times 10 to the third power, 1 times 10 times 10 times 10, 1 times 1,000, or just 1,000. Same amount of stuff, we're just describing it in different ways, depending on what our needs are. Let's see. Remember, there are a couple of important rules, but maybe the first one to remember is that we had to have one digit and then the decimal if we're talking about scientific notation, right? Okay, so remember that. Let's say I have a really small number. So remember my 10ths place, my 100ths place, my 1,000ths place, and my 10,000ths place. So to say that correctly, I would say I have 3 10,000ths with that TH on the end, right? Okay, rule says my decimal has to go after the whole number that's not 0. So I know my decimal's going to go over there. That's all the amount I have, but I want to call it by a different name. So I'm going to come over here and put my decimal here. How did I get there? I multiplied this that many times or divided by that many times. So I have a little tiny number. Remember, that's the same as that number, right? If I think about it as a fraction, 3 is obviously not the same thing. So how do I get from there to there? 1, 2, 3, 4. That's 10,000. So that's going to be a 4, isn't it? I moved it over 4 places. So each time I moved it, I'm taking that 3 and dividing it by 10. So essentially, because I'm dividing, I want to make it a negative exponent. So this is the same thing as this, right? So when I think about this, I know it's a little tiny number, so I have a negative exponent. Here, 632 is not a giant number, but it's a big number. So I have a positive exponent. So when I'm changing from a big number to a single digit, I have to multiply it by a big number. When I'm changing to a little tiny number to a single digit, I have to divide it. So it's a negative exponent. So I think that's the basics of scientific notation. Let's see. You know that 1 over 10 to the third, and let's say I don't want fractions because that gets messy. Usually, if you think about scientific notation, you're usually thinking about moving decimals around, which really isn't. It's multiplying and dividing by tens, multiples of 10. So if I wrote this, that's exactly the same thing, right? All I'm doing is saying, oh yeah, negative means it's dividing, so it's a 10th. So that's the same thing. We've got some rules for it. Okay, so write the product of 2 to the negative second power times 2 to the third power. Okay, our bases are the same, our exponents are different, and we're multiplying. So when I'm multiplying, if my bases are the same, all I have to do is add the exponents, right? So if I say that's the same thing, sorry about the dots. right? So negative 2 plus 3 is the same thing as 1. Anything to the first power is just the number itself, so that's 2. Let's see why that works. Okay, so 2 to the negative second power. Okay, so remember, that's the same thing as that, right? That negative makes it just become a fraction. Well, 2 squared is 4, right? Okay, so we know that's one of the numbers we're going to work with. We're going to also work with 2 to the third power. It's not negative. So in that case, I'm just saying 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So if I take those two numbers and multiply them, 1/4 times 8. If I want to, I can do this to make it easier to look like a regular fraction. So multiply straight across, 8, straight across the bottom, 4. So 8/4 is the same thing as 2. So I get the same answer here and here. And that's why that works, when you can just use the rule for adding exponents, as long as your base is the same. Let's see. Let's try another scientific notation one. So I'm going to make a really tiny number. I might run out of room. 1, 2, 3, 4, 5, 7, 7, 7. Okay, so I've got a tiny, tiny, tiny number. And I want to write that in scientific notation, right? So I know my decimal is going to end up right there, don't I? Because there's my first number that's not 0, and I can only have one number, one digit in front of that decimal. So what did I say I have to do? I have to divide this 7 by 10 every time I move. 1, I'm going to move 1, 2, 3, 4, 5, 6. Okay, so I know I'm going to have 7.77, and I'm going to have 6 times that I divided, but because I divided, it's a negative number. So I know that 7 is definitely not the same thing as that tiny little number, 7 millionths. Is that millions? Tenths, hundreds, thousands, 10,000s, 100,000s, millions, okay? So I know that 7 and 7 millionth are not even close. But if I take that 7 and divide it by 1,000,000, that's what I'm going to get. So I know that these two things are equal. So that's the correct scientific notation. Okay, let's see. One more. Oh, standard form. Let's do that. 2.87. And I always say it that way, but really you should say 2 and 87 tenths hundredths. So 87 hundredths times 10 to the 4th power. In standard form, so let's just write it out as a regular number, right? So I know that I'm multiplying this basically a 2 times 10,000, right? There's 4, power of 4, so it's going to be 10 times 10 times 10 times 10. 4 zeros, number 4. 4 zeros, right? So I know every time I'm going to move that decimal, I need a big number, right? Because it's 2, so I need somewhere close to 20,000, between 20,000 and 30,000. So to do that, I'm going to say 2.87, and I'm going to move it times 10, times 10, times 10, times 10, right? 1, 2, 3, 4, 1, 2, 3, 4. Okay, so I know that this scientific notation, written out in standard form, is 28,700. And that sounds about right, doesn't it? 2 times 10,000 be 20,000, but I've got that extra. So 28,700. Okay. Ooh, these dots are going to make me crazy. Okay, let's do one. 3.2 times 10 to the 3rd. I'm going to multiply that times 2.4 times 10 to the 9th. Okay, so how do I do that? I know that I can multiply my, what do you call these things? Remember, coefficient? Do that first, okay? So 3.2 times 2.4. 8, 12. Probably way faster than I have 2 decimal places, so I'm going to make it 7.68 or 7 6800ths. And over here, because my base is the same, I can say times 10, but times 10 what? I'm just going to add my exponents. So that equals 7 6800ths times 10 to the 12th power, right? So that's pretty easy. I think the trick of this is remembering what has to be the same when you can use these rules of exponents, so you'll have to practice with that a little bit. Okay, so we're going to try this again. I did one and was off the camera, so I have to try it again. This is a subtraction one. So I have my coefficient, my base and exponent, and I'm subtracting. So I notice that these exponents are different. When I'm adding and subtracting with this scientific notation, I have to make sure that these exponents are the same, right? Before I do anything else. So let's either change that to 10/4 or change that to 10/5. 10 to the 5th power. I know if I make that exponent smaller, then I have to make that number bigger, because I want to keep it the same amount of stuff, just stated in a different way. If I make this exponent bigger, I have to make that number smaller. So I don't know, I'll make that one smaller. So this is where my decimal was, but I want to change it to only multiplying it by 10,000 rather than by 100,000. So if I move it over one, then this becomes that same amount, just now has the same exponents. So now it's going to be pretty easy to subtract, right? Come over here and do my coefficients. 41.2 minus 2.02, or 2 200ths. Sorry, lots of dots. I'm missing a piece, so I can fill in any empty holes that are at the end with zeros, right? Because 2/10 is essentially the same thing as 20/100ths, right? It says something about at measuring, but for math purposes, we'll say that that's fine. Okay, so I'm going to subtract 1, bring my decimal down, borrow 9. Okay, so I get 39 1800ths. Okay, now what do I do with this exponent part? Oh, because it's the same thing, I just put it back on. That's easy, right? Okay. Okay, 7.3 times 10 to the 3rd. I like writing everything out, and sometimes it feels like a big paper waster, but it makes me understand it better. Okay, so we're adding. So I know that I have to make this and this the same. So I got to change one of them. What should I change? Doesn't matter really. You want to go ahead and make that exponent smaller, so I would need to make that number bigger? Or should I make that exponent bigger and that would make that one smaller? Let's do it that way, okay? So I am going to say 3 times 10 to the 4th. My decimal was here, but I'm going to move it over here. And if I multiply it times, and what's 10 to the 4th, do you remember? 10,000. So if I multiply that times 10,000, I get the same thing as if I multiply that times 1,000, right? Okay. plus, I should put my 0 there, sorry, 2.14 is 10 to the 4th. I'm just going to take my coefficients now and say 2.14 plus 0.73. And then I can just add my base back on. Okay, so I get the answer there. If I had done it this way and changed that one to the 3rd power, I would have gotten exactly the same answer. Last one is division. And 8 times 10 to the 6th power. Okay, so here I can just divide that and divide that. Do them separately. So let's do 24 over 8. So 24 divided by 8 equals 3. Here I'm going to subtract my exponents because I'm dividing. So that's the same thing as 10 to the 3rd power. So there's my answer. Hopefully this helps. If it confused you, I'm so sorry. More later.